In the last video, we learned that the concentration of solute in a solution elevates the boiling point and depresses the freezing point of a liquid. Solute concentration also affects osmosis. We looked at boiling point elevation, freezing point depression, and osmotic pressure in the last video. We'll look at vapor pressure lowering and some applications of colligative properties in this video. Here is a picture that shows vapor pressure. Some of the liquid molecules have enough energy to escape into the gas phase. Some of those gas molecules will be returned to the liquid. The pressure exerted by the gas on the surface of the liquid is called vapor pressure. When a solute is added to a solvent, the vapor pressure of the solution is lower than the vapor pressure of the pure solvent. Adding a solute can keep a solvent from evaporating. Let's say you ran out of gas on a really hot day and had to walk to the gas station to get some gas. You forgot the cap to the gas can. What would you add to the gasoline to keep it from evaporating? Stop the video and answer that question. Here's an answer. You have water, seawater, and 0.9% salt, which is the physiological concentration of salt in our body. Stop the video and answer these questions. And the answers are: at 25 degrees, water has a vapor pressure of 23.8 millimeters of mercury. You can look up that vapor pressure on a table online. To calculate the vapor pressure of seawater, we have to calculate the mole fraction of water in the solution. Stop the video and review this mole fraction calculation. This number tells us there's 99% water in the 0.6 molar seawater solution. From the mole fraction, we can calculate the vapor pressure of seawater. The vapor pressure of seawater is only slightly lower than the vapor pressure of pure water. Stop the video and calculate the vapor pressure of 0.9% NaCl. The answer is 23.7 millimeters of mercury. 0.9% NaCl is the same as 0.15 molar NaCl. Do the same thing we did with seawater, and the mole fraction of water and 0.9% NaCl is 0.997. In Los Angeles, shade balls were added to water reservoirs. Stop the video and think of a reason why they would do that. And the answer is, the shade balls cover the surface of the water to keep it from evaporating. Okay, so let's review. Stop the video and answer these 4 questions. And the answers are: time-release drugs release drugs to the body so the concentration of the drug is not too high or not too low. Stop the video and explain how this time-release drug works. And the answer is: water enters the drug through the semipermeable membrane and pushes on the flexible impermeable membrane. As it pushes on the flexible impermeable membrane, it pushes the drug through the rigid wall with tiny holes into the body. Milwaukee is using the salty liquid from making cheese to remove ice from its roads. Stop the video and figure out what's happening here. And the answer is: adding salt to ice lowers the freezing point of water and helps melt the ice. You have a substance but don't know what it is. A good start is to measure the molar mass. Colligative properties are used to measure molar mass. Stop the video and try question A. And the answer is: benzene is a solvent, so we know the freezing point depression. We'll assume I equals 1 because benzene is nonpolar, and we know Kf. Let's solve for M. This number tells us there's 0.66 moles of the unknown substance in 1 kilogram of benzene. How many moles of the substance are in 10 grams of benzene? So the molar mass is... Osmotic pressure is also used to measure molar mass. Stop the video and do question C. And the answer is... the molarity tells us there's 7.28 times 10⁻⁵ moles of hemoglobin in 1 liter of solution. How many moles are in 100 milliliters of solution? Molar mass is mass divided by mole, so the molar mass of hemoglobin is... we've assumed that all ions dissociate completely in solution. But do experiments show this to be true? Stop the video and answer these questions. And the answers are... using the freezing point depression equation and the data given, I equals 1.85. In theory, the freezing point of this 1.0 mol sodium hydroxide solution should be minus 3.72 degrees Celsius, assuming complete dissociation of the sodium hydroxide. So the difference between the experimental freezing point and the theoretical freezing point is that the sodium hydroxide does not completely dissociate in solution. Experiments show that other solutions such as 0.1 molar sodium chloride has an I value of 1.81. That means 90% of the sodium chloride dissociated in ions. In concentrated solutions, Ions are closer together, so ion pairing occurs. These observations tell us that complete dissociation really isn't complete. Your car's cooling system uses boiling point elevation and freezing point depression. Here are the functions of the coolant, and here are properties of the liquid coolant. Prestone coolant uses ethylene glycol. Here's the chemical formula and relevant properties of ethylene glycol. According to the Prestone label, a 50-50 mixture of Prestone water protects your engine up to 265 degrees. A 70-30 mixture protects your engine up to 276 degrees. Stop the video and answer this question. And the answer is, these solutions have boiling points higher than the boiling point of pure water. If ethylene glycol is a solvent, these solutions have a boiling point which is lower than the boiling point of pure ethylene glycol. The Arctic Ocean is very cold, and scientists found that fish contain antifreeze proteins. These proteins prevent the fish from freezing in very cold water. Here's another type of protein found in flounder which prevents the fish from freezing in cold water. Not only do some fish have antifreeze proteins, insects do as well. And other insects have an antifreeze sugar in them. A very important application of freezing point depression is ice cream. Stop the video and answer these 3 questions. And the answers are, so what we'll do in lab is estimate the freezing point of ice cream and then figure out how much salt we need to add to ice to lower the freezing point to that temperature. We like our ice cream to be creamy. The fat in the ice cream gives it its creamy texture. Ben & Jerry's is good ice cream. Lower quality ice cream, the water freezes out of the mixture. When you make ice cream, heat is transferred from the ice cream mixture to the salt ice. Remember that heat depends on mass, specific heat, and temperature. So if you can use only 500 grams of ice, how much ice cream mixture can you freeze? Stop the video and answer that question. And the answer is, also remember that the temperature of your salt and ice has to be colder than the freezing point of your ice cream. We just said a few seconds ago that in low quality ice cream, water freezes out of the mixture. That makes the ice cream taste gritty and grainy, no good. Cryoprotectant chemicals prevent water from freezing out of the mixture. And if you love your ice cream, you've probably had brain freeze.